Welcome to Oxboon, the technology magazine. Hello and welcome to Oxboon, the technology magazine. Have you counted your water today? What may sound a bit amusing has a serious background. After all, we all want the waterworks to bill our water consumption correctly. But also in the industrial sector, we depend on being able to correctly calculate liquids that flow through pipes. This means the quantity of liquid flowing through a pipe as well as the flow velocity. In the past, these parameters were measured in the pipes themselves, using an impeller that was driven by the liquid. However, the disadvantage of this method was that mechanical measurements led to wear and tear, and the impeller had to be replaced relatively frequently. So there was an interest in finding out how to look inside these pipes without having to open them. And one of the methods used for this purpose was the transit time difference method. In other words, the transit time difference method is the method that has established itself among modern methods for listening into these pipes from the outside using ultrasound, one could say. After all, we can put our ear to these pipes and hear whether water is flowing or not. But of course, for professional use, we need sensors that can not only tell us whether a liquid is flowing or not, but we also need to know how much is flowing. This is a complex measurement technology, and therefore, we need to measure a number of variables. First of all, of course, we need to know the pipe diameter as well as the material thickness and the material the pipe is made of. Many pipes also have a coating on the inside. This also has a certain thickness and in most cases is made of a different material than the outside of the pipe. This also needs to be known because the ultrasound behaves differently in these materials. The same applies to the temperature of the liquid flowing through the pipe in order to obtain the most precise measurement possible. But how can we carry out this measurement? We need sensors like this one. Here, a piezo crystal is installed at the bottom, and this crystal acts as a transmitter. It sends ultrasonic signals, and if we go over here now, take our demonstration pipe, then I can use this one, which has a magnet built into the bottom, which can easily be attached to the pipe here. And of course, we do not just need a transmitter, as it would not make any sense to send something and then not receive it, which is why we will also require a receiver here. That receiver looks very similar to our transmitter in this case. And it also works in the same way. Again, we have a piezo crystal and I attach it a little further along the pipe. And now the signal is transmitted. It penetrates the pipe and will then be received again a little further on. In this way, through this measurement, we have determined the transit time of the signal through the medium. It is also important that these probes are mounted horizontally because it is quite likely that the pipe is not completely filled with our medium, which means that there is still some air in our pipe. And as this air is lighter than the liquid, the medium, it would form bubbles at the top. But we do not want to measure the air, as that would clearly falsify our measurement result, right? We only want to measure our medium. And that is why it is important not to attach these probes to the top of the pipe. So, now we have our measurement, but theoretically, as all the required physical parameters are known, we could also calculate this theoretically. But we want to measure the movement of the liquid in the pipe. To find out how, I used this little belt conveyor. So when we switch this on, we can see how these fields move in one direction. I'll turn it off again because it makes so much noise. We're familiar with belt conveyors like this one from large facilities, such as airports or exhibition grounds, where we find it very practical to be able to stand on these moving walkways after a long day and be transported without having to walk. Now, when the belt conveyor or moving walkway is off and I, the little man here, walk over it, I'm just as fast as if I were walking next to the moving walkway. That's actually logical. But if I turn the belt conveyor on, if I walk over here now, then I'm much faster. We can do that again. Then the speed of the moving walkway and my own walking speed add up to a total speed. And in a figurative sense, the speed of the belt conveyor represents the speed, the velocity or the flow rate of the fluid in our pipe. And it is precisely this effect that is used by modern flow meters, which simplify this complex calculation and provide us with all the measured values and measurement series we need to determine the flow rate in pipes clearly on a display. Here we see a flow meter from the PCE-UFM series. The UFM series consists of a total of 6 measuring devices from UFM 4 to UFM 25. In this case, we are using the UFM 15. What does that mean? We need to be able to carry out measurements on different pipe thicknesses. And that is why these measuring instruments are supplied with brackets that are suitable for enclosing different pipes from DN4 to DN25, as I show here. In practice, we would now screw this holder in place, but we will now skip that for the purpose of this demonstration. The measuring device is now attached on here, but first I would like to show you this. So we have the piezo sensors down here again, one transmitter and one receiver. And on these sensors, if I turn this to the side, we can see a kind of foil. These coupling pads are important for ensuring that the sensor rests directly on the pipe without an air gap. We can have a look at what it looks like when the sensor is mounted on a pipe. I went into the cellar for you and attached the device there, and we can now see it in action. We can now see that a certain amount of water is running through the pipe, and we can see the live measurement. And if we navigate through the menu, we can also see that we can determine the flow quantity. But we can also see the speed at which the water runs through the pipe. Here in the studio, of course, we can only do a dry run. I will go through it again anyway. So these are the different displays which show this very complex measurement in a very simple, clear manner. So we see the speed and the flow. And when we enter the menu at the bottom here, we can see that we have various settings. Up here, we have the settings for the properties of our pipe. We have various system settings such as the current time. It is very important when we have attached the measuring device that we calibrate it to the pipe. And the output settings, for example, if we go into the submenu here, we can see that this measuring instrument has an RS485 interface and an analog current interface. This means that it can be integrated into an industrial system. The measured values can be read out remotely and monitored. And we also have the option of setting an alarm down here. When I go there, I can set the alarm thresholds, which means that I set a lower alarm value and an upper alarm value that must not be exceeded. So this is a device that is intended for permanent installation in a system. And I can show that again at the end. This is then attached here and screwed onto the bracket. The PCE-UFM series of PCE instruments, in this case the PCE-UFM 15 for a DN15 pipe. I have brought you one of PCE's flow and heat output meters here, the PCE-TDS 200+. This is a device from the PCE-TDS 200 series. And so we see that it is a mobile device for the service technician who works with the systems and has to take measurements regularly. We see a device with a very clear 2.8-inch graphic display. And I can work my way through here and we can see that graphs can also be displayed. Live measurements can be shown here on the display. And if I go into the menu of this test instrument, we can also see that we have a whole host of different settings. For example, we can enter some information about the pipes in which we make our measurements. We can select which pipe material is used here. We can also specify the wall thickness and other important information, such as the pipe's lining. And what is of course also a very important piece of information is the medium that we are measuring. The medium that flows through the pipe. So we see that it is not only possible to measure water but also various oils, including diesel, gasoline and petroleum. Let's go back again. We have the option of connecting various sensors to this device. We have the PCE-TDS 200S sensor, which I can show you here. This is a sensor for pipe diameters of 15 to 100 mm, as you can see printed on the sensor. But there is also the PCE-TDS 200M sensor, for example, which I can also show you here. You can see that we are talking about pipe diameters of up to 700 mm. And if we look at the bottom here, we can see the piezo crystal again, which helps us to carry out ultrasound measurements. And if we go further in the menu, we have many more options. Measurement methods. There are different measurement methods for attaching the sensors. Either the Z method, where we measure diagonally through the pipe. We can also use the V method, where we install both sensors on one side of the pipe and measure a reflection. Of course, the measuring device has to know which way we are measuring, so we have to enter that information. And a few other things. I would like to show you one particularly nice thing. Once we have made all these settings, we are shown graphically how we need to install the sensors, depending on the pipe material and the measurement method. And we also see a display down here. And as we can only do a dry run in the studio, of course, I went down into the cellar and attached the sensors to a real water pipe. And we can see that the quality display moves well into the green range. And also that the distance display is within the green range. And if you switch through the menus and let water flow through the pipe, we can also see that measurements are being recorded here. The PCE-TDS Plus version of this device also has connections for temperature sensors up here. This makes it possible to measure the heat output if we want to determine the quantity of heat of the liquid in a pipe. And then, when we make the relevant settings, this measuring device can also display the costs associated with the heat transfer. This is one of the special features of this device. What is also possible is that the device has an integrated data logger. I went back into the menu to use this function. And if I go in here, we can enter start conditions, stop conditions, intervals, and data records. You can record up to 10 million data records with this model. And we see a USB interface at the bottom of the meter. So it is also possible to transfer these data records to the computer or laptop. And the device can be ordered with an optional Windows software, which also helps us to analyze the data that we have collected with the device. All in all, this is an indispensable tool for a service technician when working on site. Let us take another look at the devices. First of all, we have a device of the PCE-UFM series, in this case the PCE-UFM 15, for permanent attachment to a pipe. For this reason, a corresponding bracket is also supplied. This device is capable of analyzing flows of up to 5 meters per second. It also offers the option of being connected to industrial systems to collect data. Then we have a device from the PCE-TDS series, in this case the PCE-TDS 200+. The device is intended for service technicians. It is a mobile device with a built-in rechargeable battery and can measure flows of up to 33 meters per second. This device is available in different versions. For example, with the PCE-TDS 200S sensor for thinner pipe diameters or the PCE-TDS 200M sensor for pipe diameters of up to 700 mm. It all depends on what you need for your application. The scope of delivery also includes a coupling gel, which is applied before we connect the sensors. And if we have a pipe that is not magnetic, we have magnets at the bottom of the sensors here. Velcro straps are also supplied so that these sensors can be attached there. The measuring device has a very clearly legible display, very logical menu navigation, representation by graphs, and it also actively helps us to connect the sensors correctly and adjust them properly. All in all, this is an excellent tool for technicians. That's it from me for today. Make sure you keep everything flowing and see you next time. And goodbye.
Discover and order the latest measuring and test equipment now on www.pce-instruments.com.